Okay, solve the equation by making an appropriate substitution. Yes. Okay. Now, technically this is a fourth degree polynomial, but what we could do, for instance, is we could say, well, what if u is equal to x squared? And then what we could do is we could turn this entire thing into u squared minus 29u plus 100 equals 0. And by doing that, you've actually turned this into a quadratic, and a pretty simple quadratic at that, which means you could probably just solve this through an alternate means, right? So now we know that, let's just treat this as a simple trinomial. Square root of u squared is u. It ends in a positive, but the middle term is a negative, so matching negative. Both of them are going to be negative. And two numbers that I can multiply together to give you 100 that if I add together give you a 29 would be a 4 and a 25. Right, so then that's going to be u is equal to positive 4 and u is equal to positive 25. Okay, now there was an additional step at the beginning, so there's an additional step at the beginning, right? But then you have a last step that's also, that looks like lost, I didn't realize that. Last step, Jesus. Last step. And what you're going to do is now you're going to substitute the u back for x squared. So it's x squared is equal to 4, and it's going to be x squared is equal to 25. I'll try to have better handwriting. All right, so we take the square root of both sides. It's going to be x is equal to plus or minus square root of 4, which is 2. Then we're going to say, well, square root of x squared is equal to x. We're going to have plus or minus the square root of 25, which is 5. And yes, technically this is the wrong symbol to represent this because this is the principal or the positive square root, and I'm doing both. But otherwise, it just looks like it poof goes from x squared to x. So I'm just trying to give you an indication of kind of what happened, but technically that's kind of the wrong symbol. So just be aware of that. Okay, so now this one is a little bit different in that you have a bunch of answers, right? So my math lab is going to make you break this apart into -2, +2, -5, +5. Okay, but there's also nothing really wrong with as long as your teacher allows it by just doing plus or minus 5. It's just a more compact kind of notation. All right, let's try the next one. So again, if you want to do the substitution, that's cool. It's just going to add a step at the beginning and a step at the end. So we'll do the same thing here, right? So we say, well, u is equal to x squared. Therefore, u squared minus 25u plus 144 equals 0. We do both. We end up with u here and a u here. It ends in a positive, matching, middle is negative, matching negative. All right, so we're looking for two numbers that we can multiply together to give you a 144 that if you add together would give you a -25, and they're both negative, right? Now, I haven't been writing it down, but I'll do one here. But so we're looking for two, gives you 144, right? Now, you might be tempted to do all of them, but we know that a combination of 1 and 144, it's not going to give us a 25. It's just not. So how about 2 and 72? Is that? No. Okay. What about 3? Is 3 going to work? So you'd say 144 divided by 3, and that would give you a 48. Combination of 3 and 48? No. Well, how about 4 and, let's see, a 36? Would that give it to us? No. What about a 5? 5 going evenly? And you would just do this on a calculator, right? We just say 144 divided by 1, but divided by 2, divided by 3, divided by 4. Now divided by 5 doesn't go in evenly. Divided by 6, that would go in evenly. So what about 7? Will 7 go in evenly? No. Well, what about 8? Will 8 go in evenly? Well, let's see. It looks like it. We're getting close, but still. No, we're still not quite there. How about a 9? Will 9 go evenly into there? Let's see. We have a 9 and 16. And sure enough, it looks like 9 and 16. When you add those together, you get a 25. So if you were going to do it, you can still just follow the algorithm. Some take longer than others. This one's a little longer than some. So you put a 9 there and a 16 there. So that means u must be equal to +9 and u must be equal to +16. Right, now we do the substitution. U is really x squared. And again, you do a substitution at the beginning, you do a substitution at the end. This mainly comes in handy probably when if you go further in mathematics, you get to like cal and stuff. Sometimes it's easier to do some of the steps by doing substitution. So you say x squared is equal to 9, therefore x must be equal to plus or minus 3. And if x squared is equal to 16, you would say x is equal to the square root of 16, which would be a plus or minus 4. So plus or minus 4. Yeah. Okay. So let's try the next one. So we want to do appropriate substitutions again. This one's going to be a little bit different in that we're going to say u is actually equal to x plus 9. Okay, so that means wherever I see an x plus 9, I just substitute in the u. And then I solve it like this. Right? So then we say square root of u squared is a u. Put it in the first, place of both. It ends in a positive, which means matching. Middle is positive, which means they're both positive. Both positive. We're looking for two numbers that we can multiply together to give you a 40, that if you add together would give you a 13. So it looks like it's going to be an 8 and a 5. So we know u is equal to negative 8, and we know u is equal to negative 5. But we're not done. If we substitute at the beginning, we're going to substitute at the end. So we are going to say x plus 9 is equal to negative 8, and x plus 9 is equal to negative 5. Minus 9, cancel, cancel. X is equal to negative 17, minus 9, cancel, cancel. X is equal to negative 14. So, and then to be technical about it, we want to write in set notation. And order doesn't matter. Okay, so let's try the next one. Again, we want to do substitution. U is now equal to x plus 1. So now we say u squared plus 4u plus 4 equals 0. And we factor it out. We would say there's u there, u there. They're matching, both positive, positive, positive. We have a 1 and we have a 3. Okay, so we say u equals negative 1, or we say u equals negative 3. And then we have to do substitution again. X plus 1 equals negative 1. X plus 1 equals negative 3. Minus 1, cancel, cancel. X is equal to negative 2. Minus 1, cancel, cancel. X is equal to negative 4. Do we say negative 2? And we say negative 4. And that's it.